All right, promise. People should be coming in now.
Okay. Welcome, everyone, to NovoPath Expert Speaker Series. Now we have some people still trickling in. So I'm just going to give it a few seconds and then we can officially kickstart. All right. We're going to get started because we have a lot to talk about today. So we have many of our friends, supporters, customers, and industry leaders on this call. So thank you all for being here. If you don't know us, here at NovoPath, our mission is to help laboratories run like a well-oiled machine with our LIS system. But we are also here to empower the lab community with the expertise from the industry top leaders on relevant topics, like we're going to be doing today on digital pathology. That's really how the expert speaker series came about. Today, we're going to be diving into the ins and outs of digital pathology and help you think about and frame the decision and the questions to be asked when you want to go into digital pathology or invest in it. At NovoPath, we have taken a very proactive approach to emerging trends in digital pathology by developing a digital cockpit solution. This platform is IMS agnostic. We enable the pathologists to diagnose and report the cases seamlessly, being able to prioritize cases based on their workflow. With that said, we have two distinguished speakers here, and I want to really I want them to spend most of the time here talking and sharing their experiences. The speakers are powerhouses in digital pathology, and some of you may already know them. I will introduce the first speaker today, Mariano de Socarraz. He is the CEO of CorePlus. CorePlus was one of the first labs in the United States and the Americas to implement AI for primary diagnosis, and they are also developing 3D imaging protocols in a clear environment. In 2018, Mariano led CorePlus to become a fully digital laboratory. And in January 2020, before the pandemic, CorePlus converted to 100% host-like imaging for primary diagnosis. Talk about, them being really proactive even before COVID happened, and the luck, or business luck, if you want to call it there, being ahead of the time and ahead of the curve. Mariano is also a Digital Pathology Association DPA board member. Our next speaker is Dr. Matthew Hanna. Dr. Hanna is the Vice Chair of Pathology Informatics at the University of Pittsburgh Medical Center. He's also on the board of DPA. Previously, he was the Director of Digital Pathology Informatics at Memorial Sloan Kettering, where he completed his oncologic pathology fellowship training. He has expertise in digital and computational pathology. His clinical interests include breast pathology, informatics, digital pathology, image analysis, machine learning, and clinical operations and implementation. Thank you all both for being here. Over the next 30 minutes or so, we'll have both of our speakers share their experiences pushing the frontiers of digital pathology. First, we'll have Dr. Hanna speak to digital pathology lessons learned and practical recommendations for those looking to implement a digital pathology program. Then Mariano will discuss the power of AI's role as a decision support tool in your digital pathology workflows. Finally, we will have 15 to 20 minutes at the back end for Q&A. As our speakers present, please drop your questions in the chat. We will have many answers. We want to make sure we have enough time for Q&A, and my hope is to get through all the questions as much as possible before the call ends. We will also be sharing recording of this, the recording of the webinar to all the attendees and to everyone that registered. With that said, Dr. Hanna, welcome, and please take it away.
Hi, everybody, and welcome. Really excited to give you some lessons learned from digital pathology deployments, especially as I'm embarking in this new role in Pittsburgh. There are a lot of lessons learned, and I can definitely say each individual deployment very much depends on the blueprint of your own organization. So let's kick off here. Go to the next slide, please. And so I want to be, efficient and at a very high level, talk about my top 10 list for what you need to be aware of before you embark on a digital pathology deployment. And so we will go through each of these. They each have their own slides that we'll go through, but these are the top 10 things I would consider when wanting to deploy a system for digital pathology and beyond at your own organization. Next slide, please. All right. So when we think of the digital pathology ecosystem, we think of this green box. Everybody thinks of the scanner and hardware for a scanner and a viewer for software, but we don't want to use these in isolation, especially not for a clinical deployment. We need all of these systems integrated into your other hospital information systems, of course, your laboratory information systems, electronic medical records. And then you want all these wonderful, amazing tools that Mariano will discuss in terms of computer-assisted diagnoses or machine learning models, vision language models, integrated and working together as part of the entire digital pathology ecosystem. And so these are the 7 S's that we sort of coined for success. You need sponsorship from your leadership. They are really instrumental in terms of providing funding, providing the vision, providing the approvals needed to even embark on this digital pathology journey. You need to procure scanners. You need to find space for those scanners, adjacent to where the glass slides are being generated. You need staffing. You need space for that staffing. You need to think about all of the service and maintenance contracts that come with all of the new hardware and software. Of course, you now need digital storage from digitizing all of these glass slides. And there is a large bucket of software from both an image management system and other softwares, such as machine learning models and such, that need to all be integrated into this ecosystem. And before embarking on your digital pathology journey, these are your prerequisites. You need to have a barcoding and tracking system set up. This is essentially what all of these whole slide scanners use to link these digital images to their patient records in the laboratory information system. You need to, again, identify whole slide scanners that work in your organization and for your use case in terms of the throughput, in terms of the feature set that they all come with. And you need to do a laboratory information system integration from the scanners to the image management system, or from the image management system to the laboratory information system. So there needs to be communication so that the links of these whole slide images get attributed to that patient's record in the LIS. So once you've sort of embarked on this, and hopefully your lab already has a barcoding and tracking module set up, the barcode on that slide is think of it as the gateway for that slide to enter into the laboratory information system. So the scanners will decode that barcode, and there's a lot of software messaging that happens behind the scenes that will allow for automated slide aggregation. So there's no more FTEs needing to sort of collate or aggregate all of those slides and match it to paperwork. It automatically does that. You need to make sure the scanner can decode your lab's specific barcode, whether it's a linear or 2D barcode. And then you need to think about what barcoding and tracking stations you want to add to really track the scanning workflow. And talking about lab workflow, we don't want all of our FTEs to be running around. We really want to adopt those lean principles and create a linear workflow from specimen retrieval or case accessioning to all the way through the staining, cover slipping, and drying of those glass slides, to either putting scanners in the lab, or maybe even better is a room adjacent to the lab, so that way you have a chain of custody to move those glass slides to a scanning team. They digitize the slides and they quality control those slides and give those slides back. But the goal is to have a linear workflow and streamline it. And speaking of quality control, you want to make sure that, and there are some automated software tools to do this, but if you don't have that, then you at least need to manually do this on some percentage of the cases, where you want to make sure all of the tissue that was present on that glass slide is captured in that digital image. You want to make sure that the scanner accurately decoded that barcode, so that way it actually links that slide into the patient, into the medical record. Otherwise, it will be a digital paperweight where the slide will have scanned, but it won't be available in the laboratory information system. And then you want to make sure that the slides aren't scanned completely out of focus, or they don't have other digital artifacts that can happen during the digitization process. And there are automated QC tools for this that are sort of software image analysis or machine learning models. But again, if those don't exist or you don't have access to those, you should do a manual quality control for some percentage of those cases to remediate any of these issues. And then again, you want to make sure you understand the use cases for what you can use these for. It's not just for surgical pathology. There's a large digital microbiology. There's cytology adequacies. You might be wanting live viewing needs for frozen sections. And so there are a large number of use cases that we really do every day in terms of pathology use cases, but now you can enable those with digital workflows. If you have a training institution, you want to make sure that you're incorporating digital pathology usage for your residents or for your fellows, and also using them for multidisciplinary conferences. Of course, our trainees are now asking, do you have digital pathology? Do you have machine learning at your institution? Because they know that this is something they will use in their career, and that might be the differentiator from choosing a program that has those resources and deployments versus others that don't. So we talked about scanner selection. They come in all different shapes and sizes and different throughputs. Usually your high throughput scanners are for your larger digital pathology, high volume scanning needs. Then they have lower throughputs, maybe for niche applications, for fluorescence, or if you have a smaller volume of immunochemistry. And there are different regulatory approvals for each of these instruments. Again, maybe you need live viewing needs for frozen sections where the pathologist can remotely tap into that scanner and control the slide, control the focus of that slide, which you don't usually have if you're just scanning a single plane on a high throughput whole slide scanner. So the scanners come in all different shapes and sizes. There is no one size fits all, unfortunately, but you should use what works for your specific intended use cases and what you want to accomplish in your digital pathology deployment. Then we talked about the laboratory information system interface. And so you do have to have a unique LIS interface for either each hardware device or each image management system. And so you can structure this differently. If you have a single image management system, then you can have just one point to point from the image management system to the laboratory information system. Otherwise, you do need to uniquely connect and interface each sort of scanning database to your laboratory information system. And there are costs associated with that and time and effort. And speaking of costs, you please check this out. And if you are a DPA member or want to become one, there is a lot of work, or at least check out the publication. There's a lot of work put into the return on investment calculator. And what this really is I think as it does calculate the return on investment. What I think it does very well is at least showcase all of the concepts that are available to a site like yours or an organization like yours that wants to deploy digital pathology, and will at least showcase what all is involved in terms of concepts to think about when actually deploying this. And you can actually plug in your numbers and see and play around with it as sort of a sandbox to see how it will affect your operations. And we need to also think about how pathologist workstations are now, sort of the digital cockpit. I love, Mariano's background is a beautiful monitor. We're now moving towards having high definition monitors that can make pathologists' workflows much more ergonomic, much more efficient. And instead of using smaller, low resolution monitors, so if we go to the next slide, we can sort of see the scale at which, not everybody needs an 8K monitor tomorrow, but even just looking at a 4K monitor, that's an order of magnitude different from even just an efficiency standpoint of being able to navigate those digital images, as opposed to using standard definition monitors. So There are other things outside of just the scanners that, other hardware that need to be considered to actually make this sort of a deployment successful. Also thinking of ergonomics, we teach residents on their first day to sit with their feet flat and look at with good posture at the microscope. Now that we're digitally moving to a digital workflow, we need to be able to teach proper ergonomics and orient our pathologists and other staff to proper ergonomics in a digital workflow. This also brings up the point of different input devices. Instead of using a conventional computer mouse, maybe there are more ergonomic ways to navigate these whole slide images that we previously haven't had access to. All right, we want to make sure we have sufficient bandwidth and network so that when you move a glass slide on a microscope, there's no pixels that load. So pathologists are used to having very efficient reviews of these tissue. So we want to make sure you have sufficient bandwidth and network so that the images that are being tiled on the monitors can load without any latency or without any sort of tiling as they're navigating around those whole slide images. And then data management. So something I like to say is before even thinking about the scanners, how do you know how many scanners you need? How do you know what your sort of workflow is? And so if we do a lot of the analysis of just the routine pre-analytics of how many stain slides is your lab generating, how many different subspecialties, what is the breakdown of stain tasks in terms of how many are H&E versus unstains, because you're not going to be scanning the unstained slides, and sort of understanding at a high level what will your volume be needed to actually sufficiently scan through all of your patient slides, and then knowing the information in the laboratory information system and how to manage it. Sort of tee up Mariano, there's a lot of metadata that's embedded in the laboratory information system that you'll want to know and map to other machine learning models so that your breast cancer detection model doesn't run on your prostate cancer slides. So there's a lot of data management behind the scenes that you want to get your informatics, your IT folks involved in so that you can properly set up both your pre-analytic knowledge and planning, but then your post-analytic machine learning model testing. And then, of course, I can't underestimate the change management that's involved here. Pathologists that have, historically been using their bright field microscopes and glass slides, a lot of them are used to that. It's sort of us being champions of digital pathology to help drive that additional value, help drive that change management to allow them to work in this digitally enabled environment and make them be successful in that venture. So I'll close out by saying digital pathology, the digitization of the glass slide is just sort of the bridge or the road that will lead into all of the other advantages. I don't think, the pure digitization of the glass slides, does provide value, but there's significantly more value across that bridge when we can start laying on top of the digital pathology deployment with these machine learning models and other sort of value proposition adds that Mariano will be speaking of. So this is sort of the road into a lot of the other technologies and use cases that I think you'll see a lot of additional value towards. Thank you.
Thank you, Dr. Hanna. I think there are a lot of lessons here for us, especially as a laboratory is thinking about setting up digital pathology for the first time. Now over to you, Mariano. You're one of the industry's top voices on this topic, especially when it comes to the application of machine learning, AI, and really just sort of pushing the frontiers of how, what are those use cases that digital pathology opens us up to. So I will hand this over to you now.
Well, thank you, and thank you for the invite today to participate in this wonderful seminar with the college and NovoPath. So great, and also to share time with Matt. Really have admired his career during his tenure at both institutions, and we've looked at this from a different perspective as a commercial entity versus a private university institution. So today, what we'll do is go over what our journey to AI was, what we consider a new kind of ROI, and also highlight a little bit of the traditional return on investment. Next slide, please. So this was our call to action. Ironically, this came from UPMC back in 2018 when I saw this press release from IBEX and UPMC that they were using prostate AI. CorePlus originally came and has been very strong in the urology space, uropathology space. So we've always kept up, and this was very intriguing to us. If you see in the background, we dabbled in digital pathology back in 2007, 2008 with bioimaging, and at that time we were using it for breast, ERPR, KI67. So we already had kind of dipped our toes in the digital realm, and for me, coming from the imaging side as an early part of my career, this was only natural to navigate to digital pathology. So next slide. In the interest of time, I'm going to kind of compress this. So we started with the 2018 with the press release, and we took 2019, and our goal was to be digital primary, and our use case was really to transform our practice to primary read of whole slide images. So that was number one. We wanted to really decouple the pathologist from the glass. So that was our mission, and our mission was to have this deployed by January 1st of 2020. So we used 2019 to travel around. We used to, Dr. Juan Carlos Santa, Chief Medical Officer, and myself, we would go to different courses and conventions. We would also travel around with our own slides to get them scanned, which we thought that was the right thing to do. Obviously, I think Matt showed you a little bit more of what we really should be doing. So we've learned from that time. So we were able to validate the whole process. And we went live in January 1st with primary read. And then on June 1st of 2020, we then incorporated for routine, operationalized routine use of AI in prostate. Next slide, please. So we used this, we validated using the College of American guidelines at that time. We really were able to do this from the ground up. Fortunately, we have an IT company called Syndio, and we were able to really we decided that we wanted to be kind of masters of our destiny. At that time in 2019, there was only really one company that had FDA approval, and their technology was already 7 years old, and we just thought that this wasn't where we wanted to be. So we were able to build our whole infrastructure and ecosystem from the ground up, including cabling, upgrading our computer systems, deciding on what monitors we wanted, the desks that the pathologists were going to use, things that Matt showed you, the distance, all of those things were taken into consideration. And obviously, we validated histology, immunos, and special stains. Next, please. So this is what we did. So this was the end of our, or the beginning of our journey in 2020. We started with digital pathology, and in June 1st, we started using then the IBEX algorithm for prostate. Next, please. And here's a snapshot of the validation. I think that for us, obviously 4 years into this, we were very pleased. And if you look at the area under the curve at 0.994, I think it tells you everything. And for us, when the algorithm says it's negative, we all know that there's interoperator variability. So you can read for yourself. We did this on a 3D Histech scanner and using the 0.25 pixels. So that was our initial validation. So we validated, and we really wanted to really look at benign versus cancer. We weren't so much interested yet in Gleason grading. So our focus was, can the algorithm really and truly give us a definition between benign and cancer? And that was what we wanted at the time. because we knew that these algorithms are going to improve over time. Next slide, please. And here's a study that you'll see we published over 9,000 cases where we used this first as a quality control tool. And by that, we mean that the pathologist read the case. At the same time, the images were uploaded to the server. And then there was a reconciliation with the algorithm highlighting or providing the pathologist with alerts. So when you look at this, the algorithm analyzed over 350,000 individual cores. And in this, we call it the AI impact. We were able to identify 74 instances where we would have missed. But one of the important part of this is to look at is that there is interoperator variability. Obviously, pathologists that have higher expertise in neuropathology versus those that are more general, we do have that spread, and that's been documented in the literature. We see that where neuropathologists maybe have a false negative rate of 3 to 4%, general pathologists maybe up to 13 to 15, and in some of the data I've seen from IBEX could even be higher. So this is really a tool for us to be better, to be more precision oriented, and to provide a better diagnosis for our patients. Next, please. And here's the validation that we were able to publish just recently in the journal Pathology Informatics. So for anybody that wants to dive deep into the whole process, we have that there for you. Next, please. But many calls I got was, hey, what is your return on investment? Well, we decided that that wasn't something that we really set out to do initially. We didn't know what, quote unquote, the return on investment was going to be. So we coined the name return on innovation. And I think that is really how we see this. And I think there were some of the points that you'll see today, or that you'll see in a few seconds, Matt talked about. And how do we quantify all of these different aspects that digital pathology can give us? Not just the ability to do algorithms, but just in our daily practice. Next slide, please. So we broke this down into various return on innovation. One was just operational. Again, safety, true patient identification, using barcode scanning from accessioning all the way through the system. That is crucial in our practice. And just as Matt highlighted, there's a lot of information we can put into that barcode. So when it's scanned, it knows what type of tissue it is, case number, any other parameters that we want to use, it's there. So it can really help us in our digital workflow. Then we have what we're calling the 21st century toolkit. I mean, it's, little things that are going to help you be more efficient. Measuring, I mean, just so simple tools that today, maybe in a microscope world, is a little bit more difficult. Then we talk about infrastructure and operation. And the other one here that we looked at is human resource ROI. Matt talked about ergonometrics. That's critical. I mean, how do you measure that from a return on investment? Is it occupational therapy? I mean, what are the costs associated with using a microscope versus using a monitor? And some other aspects, transferable skills. For instance, we learned when we did a tour back in 2019 at MSK, where Jennifer Zamboni showed us their scanning department. And she made a mention that instead of using histotechs to do scanning, they had photographers that used to do a lot of picture taking, and they transitioned those people. So they had the skill set to know about gamma, to know about how images should look. We decided to create a position called digitalization specialist. And we're really looking at people that come from that environment, because what we need to do is make sure we have a good image. It's hard to find histotech, so I don't think it's the right move to take a histotech to put them to do scanning. And then, as you can see, some of the other aspects. And the one thing that I find important is what I call cognitive fuel. Next, please. And here, after 4 years, we now have the algorithm doing the triage work up front. So what this has done is been able to redistribute the energy of the pathologist. Instead of looking at every case and not knowing if it's positive or negative, now you already have a triage tool that lets you know what status, the diagnostic status of each case is. So you can decide and start and review all your negative cases, your positive cases, or borderline. And as I mentioned, as we saw in our validation data, is the area under the curve is pretty significant. So one of our pathologists coined the phrase that when the algorithm says it's negative. So it's very important. So now, instead of the pathologist really spending a tremendous amount of time in different areas looking at every individual case, now we can just go right into where the important aspects are and really capture more time from the pathologist to do higher level work. So this is what I consider the cognitive fuel and how we redistribute it within our organization. Next. So we did an analysis of time savings and maybe now a return on investment of the pathologist's time. And we took in our practice that it was around 18,000 available minutes. And you could either use those minutes for other work or you could bring in additional revenue. So I think that our pathologists are about 30% more efficient using a decision support tool like this algorithm, the IBEX algorithm for prostate. Next. I won't go into this, but I also had to plug the DPA, so Matt did this for me. And next slide, please. So you have to think about these algorithms as a decision support tool. This is not taking anybody's job away. This is just to make you more efficient, more precise, gives you a sense of where you are and where you're going. Still the pathologist is in charge. Still the pathologist is driving the algorithm. I think it's very, I hate to hear the word that we're getting rid of pathologists. They have tremendous value clinically, and all I think this does is provide more time for the pathologist to do higher level work. And in conclusion, this is what we've done to date. We've done over 13,000 prostate cases using the IBEX AI algorithm, close to 2,000 breast. And now we've implemented from TechSite a PAP cervical cytology algorithm. Next. So in Puerto Rico, we have issues with cancer in both prostate and cervical. And but that's fine. I thank you for your time. Next, please. Thank you.
Great. Well, thank you, Mariano. That was really incredible. Really great insights on how we can leverage AI and some of the decision support tools to make the pathologists more efficient and obviously increase their throughput. But obviously, at the end of the day, the point is that we want to be able to deliver better quality care, and AI. I mean, there's enough proof that the use of AI, can help pathologists and can help healthcare professionals deliver better quality care. We're gonna transition to Q&A, and I know I see some questions already in the Q&A. But please, if you have some questions, drop in the Q&A. We're gonna try and get through all the questions you have. In the meantime, while you type up your questions in the Q&A, quickly, we want to show you guys, we want to take 90 seconds to show you how NovoPath, enables digital pathology. We have a short video that I can show you how NovoPath stays in the cockpit, as our speakers have talked about, as we show you the video, please again type up your questions. And for those of you who might not be able to stay for the Q&A, we're going to send the video of this webinar to everyone who has attended. So stay with us if you can, but if you can, we're going to show the video out, share the video with everyone who's attended.
Welcome to a day in the life of a pathologist utilizing NovoPath's integrated digital pathology platform. A pathologist can easily access the work list of assigned cases in the LIS alongside their preferred digital IMS viewer. Ideally, dual monitors are recommended to fully utilize this digital cockpit experience, displaying the digital image, pathology report, and LIS side by side. For today's demonstration, I will showcase this process using a single screen. From the work list, users can easily see when digital slides are available for review, thanks to visual indicators in green for ready and orange for pending. Users can also use this to sort or group their work list for optimal viewing. Once they're ready for diagnostic review, they can select the case record, which will automatically open up the LIS as well as the preferred IMS viewer. NovoPath is IMS agnostic, allowing seamless integration with any IMS viewer of your choice. This ensures that a pathologist can access the correct digital image without navigating through multiple systems. While reviewing, they can take full advantage of the viewer's features, enter in diagnostic text, review patient history, as well as order stains, all within one system. NovoPath streamlines this process by enabling users to complete multiple steps with minimal clicks. Once a pathologist is ready for report release, they can release within this window and automatically navigate to their next case. When their next case record opens up, it will also automatically open up the appropriate slide. This centralized system with integrated digital pathology workflows allows a pathologist to maintain a high-quality diagnostic standard while working efficiently and effectively with patient specimens. Thank you for your time today, and this concludes the demonstration.
Good. So, I'm going to dive into Q&A, and again, please feel free to keep dropping your questions down in the Q&A. The first question I have is really for, all the both of the speakers. I think a lot of you mentioned the return on innovation, investment, ROI, but going into this, we all know that the upfront spend is usually the hardest to swallow as you're sort of thinking about that return on investment. When you both implemented digital pathology in different ways, some of you fully, some of you, I'm guessing, is hybrid. Did the cost that you had built into your model, did it stay largely the same? Now that you've been through that whole journey, and did the benefits also play out the way you anticipated? Could you maybe talk more about, how the cost you anticipated going in, were there surprises? Share any experience for the audience would be great.
Sure. So I think, I think both of our labs were both early adopters, and there at that time there were capital costs for scanners and the other hardware and software, and many of those are one-time costs. Of course, there will be recurring costs for service and maintenance and others, but I think deploying these systems today is very different than maybe several years ago. There are some creative sort of business models that some of the scanning vendors have come up with. There are leasing opportunities. There are other ways so that there isn't so much of a capital expense up front. So there are some options that are available. Nonetheless, if these will be part of your routine workflow, you want to be able to acquire those scanners in a way that's meaningful. And then again, the return on investment will be quite different depending on where you are. If you're a distributed health network, such as UPMC, that has 40+ hospitals, digitally connecting all of your sites together is probably enough of a return on investment in itself, as opposed to actually looking at the dollars and cents of it all. And I should mention, at least within the U.S., there will be opportunities. Currently, there are some Category 3 CPT codes that are available for transmission to CMS or the American Medical Association. And once there's enough widespread use, then they may attribute an actual, relative value unit to those and convert them from a category 3 CPT code to a category 1. And then that digitization effort for primary diagnosis can actually have some additional revenue for some sites.
Well, we never did an ROI. We just wanted to do it. We thought it was the right thing to do. And the one thing I think that is critical, we talk about leadership, but we really have to talk about all of the stakeholders have to be invested from the ground up. We were able to successfully deploy this on January 1st because every single member of the CorePlus team saw the value. There was no hesitancy from any of our pathologists. All of our histotechs understood how we had to realign our workflows. And so I think that a successful deployment is triggered by having your team commit to that success. So I really appreciate, and without them, we won't be talking here today. So we really didn't look at return on investment at that time. We just wanted to go digital. We thought that was the right thing to do. But just looking at digital today, and as we've experimented, and just thinking about whole slide imaging, it's about a 20 to 25% efficiency gain, having that. The other thing is, I think that COVID has changed the way we live. And the work-life balance is important in today's world. And now our pathologists can work from home. And I think that is a tremendous advantage to many that have children, that have other types of responsibility, to be able to have that ability of having a hybrid work environment. In today's world, I think that's crucial. How do you calculate that? Maybe you'll know that when you start recruiting for your positions. So there are many advantages, not just to do AI, but just simple, everyday reading of your primary diagnosis.
And I'll just add on to that. I can't stress that point enough, but I think that work-life balance enhancement also helps our sort of patient workflows. There are many times you're waiting on one last immunostain, or you're not physically at the hospital when slides are prepared, or you're waiting for additional recuts, whatever it might be. For any other ancillary testing, you can untether yourself from your microscope and your glass slides and be anywhere with an internet connection, review those slides, and be able to output some patients' reports. I've had countless times where I've had medical oncologists or other patient-facing clinicians email me, and now I can just log into the system, access it, and not have to say, well, let me wait till I'm in my office. Or so sort of the patient workflow and care dynamic also changes, but that also provides a much better work experience and work-life balance. So just wanted to stress that point. It's a great point.
Thank you. Dr. Hanna, I know we talked about this earlier, and it sounds like, at least in situations that are hybrid, especially when you're TCPC, there is that sort of relevant use case for digital, for digital pathology. Could you maybe share more about for the labs that have a pretty strong TCPC business, how digital can really maybe be a better solution for them?
Sure. So, are you sorry, just to clarify the question, you're talking about the CPT codes for digital pathology?
No, I'm talking about TCPC business, for TCPC, and especially if you're a laboratory with a lot of TCPC business, this may be a catalyst for you to maybe want to do, look into digital more seriously, given the different challenges with just purely TCPC and having to ship slides and things like that.
I see. Yeah. So, for sites that for organizations that have multiple sites, or for even medium to higher volume labs, you know, there's a lot of value, and I mean, I think that's why we've actually seen a lot of reference labs sort of, you know, move very quickly down this pipeline where, you know, they have high volumes, they want to be able to consolidate or centralize their laboratory workflow and add a scanning infrastructure sort of at the end of that, and then they can now just digitally connect and distribute all of those cases to their pathologist, and their pathologists don't necessarily have to be, again, within the confines of that organization. And so they can much easier load balance across different expertise and subspecialties. They can digitally distribute those cases in ways that you know were not able to occur before, and then of course you know bill accordingly for their you know, TCPC coding and things like that. So it's really an enabler and changes the workflow for pathologists in ways that could not exist before, with the, you know, needing to physically ship the glass slides and risk of damage or breakage, or you know, if slides are in an archive and they can fade. The sort of immortalization of these glass slides into digital images really helps the general overall workflow.
Makes sense. And from a HIPAA standpoint, though, would you be able to access the patient information from anywhere with an internet connection? You know, is there any is there some risk there that we should be aware of?
So HIPAA is, of course, needing to be incorporated in sort of validation, and even in some of the validation studies, they do have recommendations for that you don't set up sort of you know, a work from home setup in the middle of you know, a busy area. It should be in sort of an enclosed area. Most hospitals have sort of VPN networks or virtual private networks, or you know, two-factor authentication that will you know, aside from digital pathology, they allow pathologists to access the electronic medical record remotely, to access the laboratory information system remotely. And once you have secure access into the hospital's private network, then you, of course, can review patient information, review digital images, and so, you know, HIPAA has to be taken into consideration, of course, but there are mainstream workflows that allow pathologists to access the laboratory information system and, of course, the digital images today.
Makes sense. Mariano, sorry, go ahead.
Yeah, but just to add to that, I think that, look, you know, our cousins in imaging have been doing this for years. You know, they figured it out. They read from wherever. I mean, this is really, I mean, look, we all have to be concerned about security. I mean, that is number one priority. And we read every day of different systems getting hacked. But you know, radiology's been doing this for a very long time. So all of these HIPAA issues have been resolved, and I don't think it's any different on that side. Then it's also reading an image. So, you know, it's, I think as Matt said, some of it is also just common sense. You're not going to sit around with your monitor showing, you know, all of your data.
That makes sense. Mariano, if you I know, you share the sort of experience your pathologists have today of leveraging AI and the decision support tools. If you removed all regulatory barriers, would you still have pathologists look at prostate, biopsies, or do you think that the image analysis you're doing today could be sufficient?
Well, our pathologists aren't going to just rely on signing out a case automatically. This is a decision support tool. I don't know what it's going to be like in 5 years or 10 years, but today this is a decision support tool. I think, think about an Excel spreadsheet compared to what the accountants used to use, which was those multi-column green ledgers, right? And I'm sure that people said, "Oh no, the Excel makes mistakes." Well, how many of us are going to go back to those days? So, I think that the AI is a decision support tool. Still, the expertise is in the hands of the physician, of the pathologist. This is to enhance and to provide efficiency, to provide precision, but the call is still made by the pathologist.
Makes sense. Has there been, with sort of using the decision support tools and AI, have you had any experience with the effects of, where you sort of have this cognitive bias introduced by an AI algorithm up front, in how they categorize cases as either malignant or not? And maybe the answer is no, but I'm curious, have you had a situation where the AI incorrectly categorized the case, and and how often does that happen, and how rare is that?
I think that we're always going to find areas where we can, kind of, sort of throw out the baby with the bathwater. Of course, the AI, and you do have to be careful of the bias, right? But the AI is there to support you. I think we've had one case of the, 10,000 cases where maybe the AI kind of, compromise the pathologist. But, how many cases do we miss, general pathologist, uropathologist, in any type of case? Doesn't have to be prostate. So this is just a decision support tool. So yes, there could be bias. You have to know that in your mind, and you have to be careful. And I'm sure Matt, as a pathologist, can clearly relate to that and give you a little more insight from his perspective.
Yeah, there's no test that's 100% perfect, even immunochemistry. I mean, this is just an additional test that we can add to the armamentarium of every pathologist. It's an additional data point that they take into consideration that will hopefully drive them to the right answer, to the right patient care management. And what pathologists have very high specificity. Without any AI, just think of a well-trained pathologist. A trained pathologist is very high specificity. When we see something, we call it 95+% of the time that's correct, if not much higher than that. Now, what a lot of these tools are doing these are screening tasks, finding a cancer, detecting a cancer. Pathologists can help, can be supported. And, I want to hopefully try to perpetuate the messaging that these are really patient safety nets. If these technologies are available, why not allow every patient who walks and gets care at your organization an opportunity for this additional support? Again, clinical decision support. It's a pathologist with the additional information, just like if they were to order an additional test, an immunochemistry test, a molecular test, or some other ancillary testing. And this test is sort of automated to help support the diagnostic workflow. But there are bias. I mean, there is no test that's perfect, but hopefully, the pathologist is still in the loop for, as far as I can see it. I don't think we're going to be just automated, having AI pathologists automatically reporting these things anytime soon. But that's where the sort of trained pathologist, the expert pathologist is in the loop. They can disregard false positives, and but for the other 95% of the cases, or even more than that, they are being supported in really a much better way.
Makes sense. I have one other question for both of you. This is sort of what I like to do at the end of this webinars. It's sort of prediction time, and I would love either of both of you to both sort of share where do you see the industry evolving over the next 5 years? What is your prediction for how the digital pathology world is going to change for the next 5 years, especially given some of the things that's happened the last 4 or 5 years? Where do you see the world in the next 5 years from a digital pathology and AI perspective?
Well, from my perspective, we're involved with various other technologies. I think that we call it a transformation of pathology. It's not an incremental change, but it's a transformative change. So, we're working with technologies now that we're using 3D non-destructive testing. So now, instead of creating a slide, we go directly from the core and we image the whole core. So we're working with Alpenglow. We have an NIH grant. So we're looking at the full tissue in 3 dimensions. So I think that when you start seeing these kinds of technologies that are coming about, they're really transformative. We see that now with some of the prognostic algorithms like Artera for prostate cancer. So I mean, it's an enormous amount of opportunity in today's pathology world for change with the introduction of AI and some of these other technologies. Autofluorescence, where we're looking at and creating immunos without really, running quote unquote an immuno. So, it's exciting times to be a pathologist, exciting times to bring in young people that thought maybe that this was, they're not into looking through a microscope. Now they can really work in a new world that is changing rapidly.
Yeah, I completely support that vision. And, we have this adoption curve with any given technology, any new innovative technology, where we've been in the early adopter stage, and we're definitely migrating into this early majority. We have a lot of other smaller academic centers or community hospitals that are engaging in these discussions, that are looking at digital pathology. How can it provide value for their pathologists, for their pathology organizations, for their patients that are coming to get care at their organizations? And there's also a lot of AI companies that are emerging and building really fantastic tools to, again, overlay on top of that. So, I think in the next 5 years, we'll continue to see driving adoption. We'll continue to see value propositions for this. We're starting to also see these sort of generative AI tools become integrated into our workflows. ChatGPT has sort of changed how we see AI and how we see these generative technologies. Now we can start to see them solving and aggregating data for pathologists. Instead of a pathologist picture matching in textbooks, they can circle a region of interest and have a vision language model be able to provide information and sort of have this dynamic workflow that pathologists were just never exposed to. Just the technology didn't exist. So I agree, it is an exciting time to be in pathology. And I think a lot of these other research efforts like slideless pathology will, the train has left the station. We will continue to see advanced technologies sort of come out from this digital arena. But in terms of just routine digital pathology progress, I think that will continue to unfold itself.
Excellent, great. Well, thank you all for joining today, and especially huge thank you to our esteemed speakers. This has been a very wonderful webinar, and I hope everyone who attended learned a lot. We will be sharing a recording of today's call and also the slides. If you have registered for this, we will see you all at our next expert speaker series. Thank you all for your time.
Thank you for the invite.
Thank you.